going to look at set operations and compound inequalities. So a compound inequality is an inequality that consists of two inequalities linked by and or. For example, if I have x is less than 4 and x is greater than or equal to -2. So I have two conditions that have to be met. It's kind of like when you go to order ice cream and you say you want strawberry and vanilla. You'll be happy if you have strawberry and vanilla mixed together in a swirl. If you have strawberry or vanilla, that means you'll be happy if you get strawberry, you'll be happy if you get vanilla. In this case, we have and. So both of these conditions have to be met for your swirl ice cream cone. So let's look at this in interval notation. The first one we have is x is less than or equal to 4. So I will draw that in green. X is less than or equal to 4 gives us a parenthesis at 4 and anything less. The second condition that we have is x is greater than or equal to -2. Greater than or equal means that it has a bracket and anything this way. If we were to mush these two together and combine them, then on our number line, it would look like -2 here, 4 is here. Both cases allow me to use -2, so I have my bracket. Only the greater than or equal to -2 allows the use of of 4. So using 4 will not work because it's not a common shared value. So we have a parenthesis, and these would be connected. Looking at it in interval notation, we take our same values, -2 and 4, and we keep our bracket and our parenthesis. Let's look at it again, but this time let's change it to have an or. So let's say x is less than or equal to -2, or x is greater than 4. So looking at our number line, here's -2, here's 4. So x is less than or equal to -2. So less than or equal goes this way. I can use -2, so it's going to have our bracket. Greater than 4. So greater than is not inclusive, so it goes like this. Now I'll be happy with either. So that means that this and this are both part of our solution regions. So I need to write this in our set notation, which means I have my interval and my second interval. When you have two pieces that you're bringing together, you use what's called the union symbol. So this will look like -infinity to -2. Oops, I can use -2, so let's put our bracket there. Union, which means bring together and join that with 4 through infinity. Let's try again. We have x is less than 4, or x is greater than or equal to -2. So on our number line, we have 4 right here, -2 right here. X is less than 4. Can't use 4, so let's do a bracket. Or x is greater than or equal to -2. I can use -2, so there's our bracket, there's our parenthesis. Now what's going to happen if I move these together? See how this arrow extends down? See how this arrow extends up? So if I overlap these and use them together, it is going to look like this, which means our solution set would be -infinity to infinity, or all real numbers. Let's look at one more example. So we have x is less than or equal to -2, and x is greater than 4. So here's -2, here's 4. So let's do our first one. X is less than or equal to -2. So there's my bracket, there's the arrow. X is greater than 4, there's my parenthesis. Now look right here. This one, it says and. So I need the overlapping region that is satisfied by both of these. It's like our strawberry and vanilla. We're only going to be satisfied if both cases are true. There is no overlapping. There is no place where both cases are true. So while I can draw this on the graph, there is no solution because there is no place where x is less than or equal to negative 2 and x is greater than 4. So this one is no solution. Let's look at a couple more. So following down, here's some example problems. Number 1, we have negative 3x is less than 3 and x plus 2 is less than 6. So before we can graph these and look at the intervals, we first need to simplify our inequalities. So that means here we need to divide by negative 3 on both sides. Do you remember what happens when you multiply or divide by a negative? So we need to switch that inequality sign. It was less than, so now it's greater than, and negative 1. Now we need to solve over here, so we'll subtract our 2 from both sides. When we do that, we get x is less than 4. So let's draw our number line. I'll put negative 1 here and 4 here. So we need to graph x is greater than negative 1. There's no equal sign, so let's use our parenthesis, and that's going to go this way. And then we need x is less than 4. It's going to go this way. So this interval right here is where x is greater than negative 1 and x is also less than 4. Looking at it in interval notation, we can't use negative 1 or 4, so it would be an open parenthesis in both cases. Let's try again. Number 2. Negative 2x plus 1 is greater than negative 11, or x plus 1 is greater than 10. So let's solve them one at a time. For this one, we need to subtract 1 from both sides. So negative 11 minus 1 is negative 12. We need to divide both sides by negative 2. But I'm dividing by negative 2. That number I'm dividing by, right there, it's negative. So that means I have to switch my inequality sign. And a negative divided by a negative is a positive. So that's going to be positive 6. Over here, I need to subtract 1 from both sides. 10 minus 1 gives me 9. Looking at our number line, 6 is here, 9 is here. I have or, so I need x to be less than 6, or I need x to be greater than 9. It's a parenthesis here, less than 6, parenthesis here, greater than 9. So looking at this in our interval notation, I have 2 solution intervals this time. I have 2 areas of numbers that will work. So we have negative infinity through 6, and then that's going to be unioned with 9 through infinity. Let's try again. Number 3. We have 3x minus 2 is less than or equal to 7, or 2x plus 1 is less than or equal to 9. So let's simplify this one down. We add our 2 to both sides, divide both sides by 3. Over here, subtract 1 from both sides, divide both sides by the 2. Let's look at our number line. So here's 3 right here, here's 4. I have an or. This is x is less than or equal to 3. Oops. copied the problem wrong. That was supposed to be a -2. Let's fix it. I divided by a negative, so I need to switch my inequality sign. Let's fix this. So that's going to be -4. There we go. There. X is less than or equal to 3. So that means I have a hard bracket and anything this way. And here we have x is greater than or equal to -4. So I have a hard bracket and anything that way. So it's going to give me all real numbers. See how it's or? So we're looking for either case to be true. So that means my interval is -infinity through infinity. Let's try again. -3x is greater than or equal to 3, and 2x minus 3 greater than or equal to 3. So here we need to divide by our -3. We're going to divide by a negative, so we have to switch our inequality sign. 3 divided by -3 is -1. Here we add 3 to both sides, and then we can divide by our 2. 6 divided by 2 gives us 3. On our number line, x is less than or equal to -1. So here's our bracket. X is greater than or equal to 3. Now we need and, so we need the overlapping region. There is no overlapping region in this case, so this one has no solution. Let's look at number 5. We have x is less than or equal to -2, or x is less than or equal to 6. Nothing to simplify down in this one. We can just go ahead and draw our number line. So here's -2, here's 6. So x is less than or equal to -2. So here's my bracket. Less than or equal looks like that. Or x is less than or equal to 6. So here's my bracket. Looks like that. You see how this piece is going to completely overlap the portion from the -2? So that means if we write this in interval notation, everything starting at -infinity all the way up to 6 will be a solution to our inequalities. Let's try one more. X is less than or equal to -2, and x is less than or equal to -7. So again, nothing to solve. Let's just go ahead and put it right on our graph. So here's -2, here's -7. So x is less than or equal to -2. Here's our bracket. It's going to go this way. Now this time it says and. So if we have and we need and x is less than or equal to -7. So here's my -7. Here's my less than or equal to -7. Do you see how this part right here is where they start overlapping? So because it says and, that means my solution range is going to be this piece. So that would look like -infinity all the way up to -7. I can use -7, so we'll have our bracket.